My name is Victor, and welcome back to another ALINT-PRO tutorial. In today's video, we will use Riviera-PRO in conjunction with ALINT-PRO to run through the full flow of design verification. This process begins with source files created in Riviera. These files are then linted in Alint and then taken back to Riviera to run a simulation. If the design also involves a clock domain crossing, or CDC, the project can be reopened in Alint to generate CDC assertions. Then we can use those assertions back in the Riviera simulation. So, in order to begin, we'll go ahead and open up whatever source files we have. And in this case, we can go over to File, Open Workspace, and we'll be using this example from the ALINT-PRO examples folder. Specifically, if we take a look at the base directory of ALINT-PRO, we click on Examples, CDC, and Axis-CDC. Now if we click on the Riviera Workspace, we open up the following. You'll notice that there are 6 files, but only one of these will be the source code that you will need for this first step. So the first step we'll do is compile our design to ensure that there aren't any typos or silly compilation errors. But before I do that, I need to ensure that I'm only compiling the files which I would have at this point, which are the source files. So what I'll do is I'll go ahead and exclude these files from compilation. And so now only my source file is going to be compiled. So I can go ahead and compile these designs. And it looks like we're looking good. Alternatively, I could have also simply just compiled this file. So now the next step, we'll be moving on to ALINT-PRO and converting this workspace over to an ALINT-PRO workspace. In order to convert our Riviera-PRO workspace into an ALINT-PRO workspace, we will first need to be inside of ALINT-PRO. So from here, we can go ahead and open up our Tools, Convert, and then click Riviera-PRO Workspace. So you'll notice here, we can select our Riviera-PRO Workspace file. And here it pops up, which can then be converted to an ALINT-PRO file. This will be located in the same directory, but will be used for ALINT-PRO and be a workspace for only ALINT-PRO. If there are any existing files currently there, we can also overwrite them. At the moment there are, so I will overwrite them. And this is just an indicator to see exactly how the file structure will work. And it seems that we have all 6 of our files, so we should be good to finish. And so now we have our ALINT-PRO workspace, and our directory looks all correct. So now we can continue with the next step. So this next step is going to consist of running our flow manager. In particular, we'll be running the CDC analysis from ALINT-PRO. But in order for us to do this, we need to ensure that only the files used for linting are going to be included within the linting process. So here I can select those bottom 4 files and click on Exclude File. And now only these top 2 files will actually be used for the linting process. Let's go ahead and open them. So we can see here that we have our original source file. This is unchanged. However, we do have the addition of the .adc file, which is simply used for the CDC constraints seen over here on the right side of the screen. And now what we can do is we can go ahead and run CDC analysis. And after this is done running, we'll see that all of our quality and critical rule checks are completed and correct. So now that we have all of that done, we can go ahead and move on to the next step in our process. So now that we're back in Riviera, we can go ahead and begin our simulation. Now, in order to simulate this design, we have 3 simulation files here that I will include in the compilation now that we've moved on to the simulation stage. And I'll go ahead and compile this entire design. And since we've successfully compiled, I can go ahead and bring up my waveform view. which is located here in debug waveform. And then I can go ahead and begin my simulation. So I'll go ahead and initialize using the top_TB as my test bench. And while that's initializing, I'll go ahead and take a look at the top_TB. You'll notice that there are 4 modules here, 3 of which are instantiated and 1 is commented out. This first one is the axis_CDC, which is the source file. And these other 2 are going to be the driver and response modules, which are in control of sending stimulus and reading the results of that stimulus. And finally, we have the CDC assertions, which will be used in a later step. However, now that our simulation has finished initializing, we can go ahead and open our waveform and add in all of our objects. And now that our objects are added in, we can go ahead and run our simulation. And now that our simulation is run through, we can go ahead and take a look through the data as well as the waveform to verify that our design has worked correctly. At this stage, this would result in possibly changing the test bench or the source files. But in this case, we're going to leave it at that and assume that any error correction has been done by now. So now that our simulation is complete, we can go ahead and move on to the next stage, which is only required if your design utilizes CDC. Now that we're back in ALINT-PRO, we can go ahead and generate our CDC assertions. This will be utilizing both the source file or files, as well as our design constraints file, which will remain unchanged. All that we need to do before we generate our assertions is go to the properties and name our top level instance. In this case, our top level instance is DUT, so in the settings we need to ensure that we put DUT for the top level instance name. We can rerun the CDC analysis once more. And now that the CDC analysis is finished, we can go ahead and generate our CDC assertions. There is already a CDC assertions file in this project that was added preemptively, but it's an exact copy of the one that was just generated. However, there's a difference in that they are in different locations. This one is within the project, and you would need to move it from the CDC assertions folder within the ALINT output folder and the functional folder. So that would be this folder here. However, since we already have that file added, we will go ahead and move on to the next step, which is going to be simulating with assertions. Now that we're back for our last step in Riviera-PRO, we can go ahead and include the CDC assertions to our compilation, and then compile our design. Now that the design has been compiled, we will want our waveform open, as well as the assertions tab open. We can initialize the simulation and add in the objects into our simulation so that we can view them on our waveform. And finally, we can do the same step as before, which is to run our simulation. And we'll notice that on the left-hand side in the console, as well as within the waveform, we get the exact same results as last time. However, we also have results given to us from this assertions tab, which was covered in a previous video. These assertions can be used for error checking in terms of CDC analysis, and in this case, it looks like our handshake synchronizer has done the job correctly, according to our assertions. That's it for this video. Thank you for watching.